2006, NASA launched the New Horizons probe to explore the then ninth planet of the solar system, Pluto. After traveling for 9 years, New Horizons reached Pluto and became the first spacecraft to visit the far-flung world. Today, the probe has crossed the mark of 50 astronomical units from Earth. That's more than 7.5 billion kilometers. But data from the Pluto flyby is still being analyzed by astronomers. And now, new studies suggest that Pluto is alive and isn't as calm as it seems. But how did astronomers reach this conclusion? What was the strange thing they saw in the pictures sent by the New Horizons probe? And most importantly, does this discovery hint at the possible existence of life on Pluto? Pluto is an icy world with a heart of frozen nitrogen and carbon monoxide ices. It was the first object ever discovered in the Kuiper Belt and is still the largest known body in that region. However, beginning in the 1990s, when several objects of comparative sizes were discovered in the Kuiper Belt, Pluto's planetary status started being questioned. And in 2006, the International Astronomical Union reclassified Pluto as a dwarf planet. But that didn't make it any less of a target to be explored by humankind. The New Horizons pictures have revealed something completely astonishing and unexpected that has never been seen on any other planet in the solar system. The images of Pluto's surface have shown many bumpy volcanoes raised to different heights. And surprisingly, unlike the rest of the planet, there are no impact craters from asteroids or meteors nearby. In addition, there was no evidence of plate tectonics activity that play a crucial role in mountain formation on Earth. All these factors together hinted that this surface was formed after a geologic disturbance, possibly a volcanic eruption that took place recently, definitely within the last 2 billion years. Okay, I know 2 billion years seems to be quite a long time, but considering the cosmic timescale, it's not that long and can be classified as a recent event. Talking about Pluto's volcanic features, 2 peaks towering over the dwarf planet's surface have puzzled planetary scientists for years. The first one is a mountainous feature called Right Mons. This surface entity is about 150 kilometers wide, bulges up to nearly 5 kilometers above the surface, and has a central depression that is almost 50 kilometers across. Then the second feature, named Picard Mons, rises to nearly 7 kilometers and has a width of around 225 kilometers. You would be surprised to know that even though Pluto's diameter is just 1/6 of Earth's, this volcano's total volume is similar to that of Hawaii's Mauna Loa, one of the biggest volcanoes on our planet. These gigantic surface features sit at the southwest edge of the Sputnik Planitia ice sheet, which is the lighter region on the left of the famous heart-shaped feature on Pluto, and were first spotted when the New Horizons spacecraft flew past the planet in July 2015. This sheet is characterized by an ancient impact basin nearly 1,000 kilometers wide and is dominated by folds and rises that appear like wrinkles over a smooth cover of ice. There also exist several volcanic domes in this region, with most of them tending to merge into a bigger dome. After carefully analyzing the images captured by the New Horizons, researchers speculate that the formation of such a terrain must have been fueled by multiple eruption sites located near each other, and possibly the material ejected during the resultant cryovolcanic eruptions coated the entire region with layers of ice. A detailed study also reveals that the surface material in this region is primarily water ice, and not nitrogen or methane ice, as usually found in younger parts of the planetary surface, and this further solidifies the possibility of cryovolcanic activity. But for volcanoes to be active, a constant heat source must exist to drive the eruptions. For instance, on Earth, energy for volcanism primarily comes from the radioactive decay occurring in the Earth's interior. In other cases, this heat can also result from the tug and pull caused by the gravitational interaction with massive neighboring objects. That's the dominant phenomenon driving Io's volcanism. But as far as Pluto is concerned, both these possibilities don't go well with it. Neither of the planet's neighbors are strong enough to generate sufficient tidal and gravitational forces to warm its interior, nor the amount of rocky material present inside Pluto's core is enough to generate heat from radioactivity. So on in all, Pluto has an average surface temperature of almost -240 degrees Celsius, with a rock-like, hard, icy surface that cannot melt quickly so far from the sun, and not even with other heat sources. So where does this heat come from? Considering all the points, the only plausible scenario is that the dwarf planet still has leftover heat from its formation trapped within it. most likely in a deep water ocean beneath its icy crust. Even other icy bodies in the solar system, such as Saturn's moon Enceladus and Jupiter's moon Europa, are known to contain such oceans. In addition, Enceladus has shown evidence of regular cryovolcanism by spewing icy material out into space and replenishing one of Saturn's rings. Nevertheless, huge piles of icy volcanoes spread out in a field emerging to recycle an icy surface have not been observed anywhere in the solar system except Pluto. But one must not forget that the New Horizons only made a flyby and observed the region just for one day, so it's still difficult to confirm if cryovolcanism is still active on Pluto or if the exotic ice volcanoes have become dormant. And if it is still active, it would strengthen the possibility of finding a liquid ocean there and, who knows, maybe life too.